Hi guys, we're going to start chapter 8 now, and I want you to turn to page 445 and we're going to read why you should learn about systems of equations. In today's highly competitive world, businesses are constantly looking for solutions that will reduce costs and conserve resources. Highly skilled problem solvers use tools such as systems of equations to find optimal solutions. Scientists write and solve the systems of equations to determine how one set of conditions in an experiment or in the environment affects an outcome. Business owners use systems of equations to determine the cost of products or services they sell and to find break-even points when revenue equals or exceeds those costs. Pharmacists use systems of equations to mix prescriptions to the appropriate strength. Bank officers utilize systems of equations to establish the cost differences in payment plans. Consumer advocates write and solve systems of equations to figure out which companies offer a better value. In this chapter, you will learn how to write and solve systems of equations. You will solve systems of equations in a variety of ways. So, lesson 8.1 on page 446 says solving systems of equations by graphing and tables. Okay, and the objectives of this lesson are to solve systems of linear equations graphically and to solve systems of linear equations using a table. So we're going to learn two different ways to solve systems of equations right now. Alright, the first way we're going to learn is by graphing. Mr. Cassidy is trying to choose the best one-day rental plan from the A1 rental agency. The agency offers two rental plans. Plan 1, $30 per day with unlimited mileage, and Plan 2, $20 per day plus 10 cents per mile. We want to find out which is a better one-day rental plan. And we're going to solve by graphing. A system of linear equations consists of two or more equations that have the same variables where each equation represents a line. When graphing a system of linear equations, the point where the graphs intersect is the solution or the break-even point. So in example 1, it says that we need to find out which one-day car rental plan Mr. Cassidy should purchase. The solution is to compare the two car rental plans, model each with a function. So we're going to choose to let C1 represent the cost under Plan 1 and C2 represent the cost under Plan 2. And we're going to let N represent the number of miles driven. So if you look at the top of page 447, you have Plan 1. The cost of it is $30. So C1 is going to equal 30. Then we have Plan 2. The cost of that is 10 cents per mile times the number of miles driven plus $20, which is the base cost. So C2 equals 0.10 N plus 20. Plan 1 is a constant function. Plan 2 is a linear function with slope 0.10 and y-intercept 20. Graph the two functions on the same coordinate axis to see the solution. And as you can see, they've done that there for you. And where the two lines cross is the break-even point, okay, or the solution to this problem of system of linear equations. The graph shows that the break-even point occurs when the x-coordinate is 100. So here's what Mr. Cassidy has found out here. This is what this means. Both plans cost the same if Mr. Cassidy drives exactly 100 miles. Plan 1 is less expensive if he drives over 100 miles, and Plan 2 is less expensive if he drives under 100 miles. So Mr. Cassidy needs to decide what his trip is going to be. If he's going to drive exactly 100 miles, both plans are the same, he can choose either one. If he's going to drive less than 100 miles, then he needs to choose Plan 2 because Plan 2 will actually be less expensive if he drives under 100 miles. But if he's going to go over 100 miles on his trip, then he needs to choose Plan 1 because it is less expensive if he goes over the 100 miles, which is the break-even point. So for your ongoing assessment, it says solve the system of equations by graphing. And it gives us two equations here, x minus y equals 3 and 2x plus y equals 3. And so we have to solve these equations for y. We need to put them in slope-intercept form, okay? And so for this one, we're going to subtract x from both sides, and we're going to get negative y is equal to negative x plus 3. Okay, but this is negative y, which essentially means the opposite of y. So we need to come over here and change these signs so that we can get what y is equal to. So y is equal to positive x minus 3. And all I did was change negative x to positive x and positive 3 to negative 3. Now, for this one down here, we need to get y by itself, so we're going to subtract 2x from both sides. So y is equal to negative 2x plus 3. Okay, and I'm going to go ahead and graph these two lines. Okay, we have our slope-intercept form. So for this one, the y-intercept is negative 3. So I'm going to come down here to negative 3 and plot my first point. And then the slope is 1 over 1. So I'm going to go up 1 and over 1. Up 1 and over 1. Up 1 over 1. Okay, and now I just need to graph this line. And there we go. Now for the next one, I'm going to lines will intersect to give us our break-even point. So we have y equals negative 2x plus 3. So positive 3 is our y-intercept. So I'm going to go here and put a positive 3, put a point at positive 3 for my y-intercept. Okay, and then my slope is negative 2 over 1. So I'm going to go down 2 and over 1. Down 2 and over 1. Down 2 and over 1. So about right there. I'm going to go ahead and draw my line. Okay, and so you can see that these at the point 2, negative 1. So right here, you can see where they intersect, okay? 2, negative 1. And so our solution to this problem, we solve the system of equations, and the solution is 2, negative 1, because that's where the lines intersect on the graph. And this is how you solve system of equations using graphs. So now we're going to learn how to solve a system of equations by using a table. It says the solution to each linear equation or function is a set of ordered pairs. To solve the system, you must find all the ordered pairs that solve both equations. The ordered pairs represent the points of intersection of the graphs of the system of equations. So example 2 says solve the system of equations by using a table. It gives us two equations, y equals 3x minus 5 and y equals negative x plus 7. You're going to make a table for each equation, and you're going to show the values for each equation in the tables, okay? And so you can see they've done that there for you. So for this one, for this equation, when x is negative 1, y is going to be negative 8. When x is 0, y is going to be negative 5. When x is 1, y is going to be negative 2. When x is 2, y is going to be 1. When x is 3, y is going to be 4. And when x is 4, y is going to be 7. And when x is 5, y is going to be 10. Okay? And then for this equation, when x is negative 1, y is 8. When x is 0, y is going to be 7. When x is 1, for this equation, y is going to be 6. When x is 2, y is going to be 5. When x is 3, y is going to be 4. When x is 4, y is going to be 3. And when x is 5, y is going to be 2. Now, how did I figure these numbers out? Well, the book chose these x values for you, and you would just plug these x values into where x is in the equation, and then you would solve the math problem. For instance, if you put -1 here for x and you multiplied 3 times -1 and then you subtracted 5, you would get -8. And so that gives you your value for y. Okay, and that goes for all of these. You just plug those x values in. Okay, and so now if you look, that is the same. Okay, so the solution then is that point, the point that is the same on both lines. Okay, so the solution for this system of equations using these tables is 3, 4. Alright, and then on page 448 it also has an activity of using your graphing calculator to solve a system of equations. And so I want you guys to practice that on your graphing calculator now, and we'll talk more about that tomorrow in class. Thank you.